Good morning, everybody. Welcome to Wednesday. Today we're going to be continuing our discussion from last week about chemical reactions, um, and we're going to be talking about the 5 different types of chemical reactions. So grab your notes and let's get started. Basically, as we talked about last week, a chemical reaction happens when the chemical composition of a substance changes. So it was one or more things, and it's changed into one or more completely different things. The way that that happens is all of the atoms, all of the elements basically get rearranged. Um, I often like to think of it as you can buy those Lego kits and it has all the pieces where it could be a truck or a boat or a plane or a building or whatever. But you can rearrange those Legos to be all those different things. But you can't rearrange them to be a elephant or maybe a semi truck as opposed to a little truck. So it can't be just anything. But within what Legos you have, it could be a bunch of different things. So chemical reactions are kind of like that. Those pieces can turn into different things. They can't turn into just anything, but they can rearrange to form different things. Um, Chemical reactions occur based on something called the collision theory, which basically just says that all of the atoms have to actually bump into each other in order for a chemical reaction to occur. Um, and we'll talk about the collision theory in much more detail in a future unit. But basically, that's it. There's got to be some interaction of bumping into of the different atoms. There are a couple of things that will give you evidence that a chemical reaction has occurred. Um, there might be a light produced, light energy. There might be a solid formed, which is also called a precipitate. It's basically just a solid is formed from two liquids. There might be a smell or a gas that is released. If there's not an odor, you can tell that a gas is being released because it'll bubble. Just like your soda bubbles when you pour it from a can into a cup, those bubbles are evidence of a chemical reaction taking place. The carbonation in the soda combining with the oxygen in the air. There might be heat, it's another type of energy. There might even be a flame, which is light and heat energy. Um, Heat might be absorbed, so it might get colder. There might be water produced. There might be a color change. And you might see, well, or I shouldn't say or you might see a completely different property from what you started out with. That's like we talked about with the sodium chloride, right? Where the sodium and the chlorine are both very dangerous, but the combination of the two gives you salt, which is not. So the properties of the products are completely different from the reactants. Here's just some pictures of different chemical reactions. Obviously, with the first one, there's a flame. That was one evidence. The second one across the top, you see a color change. You also see smoke. There is the effervescence. That's one of those Alka-Seltzer tablets that bubbles. And then finally, you can see different properties between the two. Rotting of fruit is definitely a chemical change. So there's some reaction going on there. Um, the 5 types of chemical reactions. The first one is called a double displacement, and it happens, and I will show you examples of all these, so don't stress. But it happens when two different compounds react to form two new compounds. Um, so basically, you have a swapping of partners between the cation and the anion. A single displacement reaction occurs when you have one uncombined element and it replaces another element that's a part of a compound. Then there's a synthesis reaction. It's just like it sounds, it's when two or more simple things combine to form one complex thing. So it's a coming together. Decomposition is the fourth type of chemical reaction. And again, just like its name says, you have a complex thing that breaks down into two or more simpler substances. The final type of chemical reaction is combustion. It is a type of double displacement reaction where a compound is basically burnt, right? So you got oxygen, and then the products are carbon dioxide, water, and heat. So let's talk about why these reactions are important. Why does it matter that there's different reactions, right? Most reactions will fit into one of these categories. There are some exceptions, but they are rare, and we probably won't talk about any of them. But the important thing is scientists can use these reaction types to predict products. This is how scientists come up with new medicines, how they come up with new types of paint or stronger concrete, um, or stronger fabrics, or different food that lasts longer, milk that you don't have to refrigerate, right? So by predicting what will happen, what if we take this and this and combine them together? And by following the basic rules, they can predict what the product will be. And one little side note, being able to write an equation doesn't mean that a reaction will actually take place. Right? So you can write a recipe for something that won't turn out or that won't give you any reaction at all. So that's just something to kind of remember. All right, let's look at some of these reactions in greater detail. The first is a double displacement reaction. Remember, we said this was where two compounds react to form two new compounds. Sometimes it is called double replacement. You see here the general formula. We have AX plus BY. And basically, the A and the B switch places, or the X and the Y switch places, or how you want to look at that. But we end up with A and the Y, so the cation A with the anion Y, and then B with X. So basically, they just flippy flop. In a double displacement reaction, it's important to note that one of the products, those are at the end, must be either a solid, a liquid, or a gas. And in the chemical equation, those will be designated which is which. Because it's part of the recipe, it's important to know that will always need to be designated. There's a special type of double displacement reaction that I just want to mention. It is called neutralization. Basically, what you have there is an acid and a base reacting together to produce a salt and water. We will talk about those in great detail when we talk about acids and bases. Here are some examples of some double displacement reactions. Here we have calcium hydroxide and hydrochloric acid, and you can see the cation calcium switches to pair with the anion chlorine, and then the hydrogen and the oxygen combine together to form water. The AQ here in the formula stands for aqueous. That basically means that it is a solid dissolved in a liquid. So when you have a solid dissolved in a liquid, like salt water, sugar water, that is how it is designated in the recipe. So all of these are solid dissolved in a liquid, except for water, which that's an L for just liquid. Another example, you have sodium hydroxide and cupric chloride or copper chloride. And you can see again the sodium and the chlorine combine to form salt, and the copper and the hydroxide is what this is called, combine to form this copper hydroxide, which the S stands for solid. So you can see that's a solid. And as you notice, in each of these reactions, one of the products is either a solid or liquid. This case we don't have any gases, but it would have a G, right? Just like this has an L. Instead, there would be a G there. Second type of chemical reaction is a single displacement reaction. This is where we have one element that replaces an element in a compound. So again, there's that swippy swap action going on, but this time, if you look at the formula, A is something by itself, and it takes the place of the cation in this compound, or the B. So, like I said, cations replace cations, and anions will replace anions. So positive only replaces positive, negative only replaces negative. In order for a single displacement reaction to occur, remember I said earlier there are times when we might not get a reaction. So in order for a single displacement reaction to occur, it's got to follow what's called the activity series. The activity series is an arrangement of elements that basically says how likely are they to form a chemical reaction. How likely are they to react? It only works for these single displacement reactions. There are two different types, one with halogens and one with metals. So the rules for these activity series are that elements can replace any element below it on the periodic table, or on the series, I guess, but not any element above it. And that activity decreases as you move on down the group. Remember, the halogens is group 17, so fluorine, chlorine, bromine. And metals higher on the list will replace metals lower on the list, just like we said. A metal that is lower on the list is not going to replace anything above it. And like I said, there can be no reaction. So we would write NR, meaning no reaction. And the last rule is the further apart two elements are, the more likely the higher one will replace the lower one in the compound. Here's some examples. You can see the first one, you have copper or metal reacting with silver nitrate, and the copper and the silver basically trade places. So the silver is left by itself. The copper nitrate is then mixed with the nitrate. The copper is. And then the second one, you have lithium metal reacting with water to form lithium hydroxide and then hydrogen gas. So you can see the lithium is by itself. It takes the place of the hydrogen. So then the lithium is with the hydroxide and the hydrogen is by itself. All right, so make some predictions. Will there be a reaction or no? The first one, the silver with the copper nitrate. If you look at the periodic table, because silver is below copper, remember it won't go up, so there's no reaction. The silver will not take the place of the copper because it can only replace things that are below it. The second one, fluorine is a halogen, so you look in group 17. Fluorine is above bromine, so there will be a reaction because the fluorine can drop down. For the next one, you look magnesium and zinc. Magnesium is in group 3, zinc is in group 4. So because magnesium is higher than zinc, there will be a reaction. And then the last one, you have the halogen again, you have bromine and iodine. And if you look, bromine is above No, sorry, iodine is below bromine. So the iodine will not react and pop in there and take over. So there is no reaction there.